This is a review for PC 9. The first two problems you can solve simply using a box, and 3 through 8 require the Xbox method. Let me show you. We can draw either a hashtag like this or a 3x3 box, and we're going to put in 3x squared in the middle, negative 4x, 3x, and negative 4, like so. You could switch around these negative 4x and positive 3x terms. That part does not matter, but the ax squared and the c terms have to be in those spots. When we did the box method in the past, we started with these outside numbers and we worked our way in. This is called the reverse box method because we start with the numbers inside the box known and we try to figure out what these outside numbers have to be. For example, what are two factors that multiply to make 3x squared? It turns out those factors are 3x and 1x. And where I write them is very important because 3 lines up with 3 down here, and 3 multiplies evenly into 3. But if I had written 3x over here, 3 does not multiply evenly into negative 4. So that would create a fraction. So figure out two numbers that multiply to make 3, and make sure that they go evenly into the numbers they're across from. 3 goes into 3, 1 goes into negative 4, so we're good. That's the next step. We try to figure out these outside numbers here. We do this by saying 3x times something is a positive 3x, and that's just 1. 1x times something is negative 4x, and that's just negative 4. To write out our factors, we take 3x minus 4, which was this part here across the top, and we write it in parentheses. We do the same thing with the other side, x plus 1. And we're done. We don't have to solve this one for 0 because we are just identifying the factors. For number 2, same steps, but then we add another step at the end. So we'll start with our 3x3 box. We'll put 5x squared in the middle, 20x, 2x, and 8. We'll start with our 5. What are two numbers that multiply to give us 5? Well, 5 times 1. If I was to put the 5 here, it doesn't go evenly into 2. So I'm going to put it here instead. 5 times what gives us 20? Well, that's 4. 1 times what gives us 2? And that's 2. So x plus 4 is one of my factors, and 5x plus 2 is my other factor. To find the zeros, though, I set both of these equal to 0, and then I solve. This is a one-step equation. When I subtract 4 from both sides, I get right to my answer, negative 4. On the right, I have to subtract 2 from both sides, giving me 5x is equal to negative 2, and then I divide by whatever's in front of x. So x is equal to negative 2/5. And we can leave that as a fraction. It's actually easier if you do so. Starting with number 3, we're going to use the Xbox method because this b term is not split. So we need to identify how to split it. We'll start with drawing an x and drawing a 3x3 box. On the top of the x, we're going to put a times c. So that is 2 multiplied by a negative 12, which gives us negative 24. On the bottom of this x, we're going to put our b value, which is negative 2. And in the x, we know that, in the box, we know that 2x squared and negative 12 go there. The next step is to figure out what these two numbers are. And this is that same factoring riddle that we've been doing all along. What are two numbers that multiply to give us negative 24, but they add to give us negative 2? So if you're not sure, you can try dividing the top number by 1, then divided by 2, then divided by 3, so on and so forth until you find your answers. It turns out if you take negative 24 divided by 4, you'll get negative 6. If we use the two factors, negative 6 and 4, they multiply to make negative 24, and they add together to make negative 2. When I put them in the box, I'm not going to write it as negative 6 and 4, though. I'm going to write it as negative 6x and 4x. So then, with 2x squared, I look for factors. 2x times 1x gives me 2x squared. So 2x times something is negative 6x. I can put a negative 3 here. And 1x times something is 4x. I can put a 4. My two factors are x minus 3 and 2x plus 4. Notice I got those by going across the top, x minus 3, and down the very left, 2x plus 4. For number 4, same steps, but then more at the end. So I'll start with an x and a 3 by 3 box. I know that a times c, or 9 times negative 8, is a negative 72. And on the bottom is my b value, which is a negative 6. In the box, a 9x squared and a negative 8 go here. And I try to figure out two numbers that multiply to make negative 72 and add to make negative 6. Those two numbers are negative 12 and positive 6. When I put them in the box, I add the x. Then I think of factors of 9. Well, 9 times 1 would not work, but 3 times 3 does, so I'll put 3x and 3x. 3x times what gives me 6x? That's a 2. 3x times what gives me negative 12x? That's a minus 4. So I'm going to take 3x minus 4 and set it equal to 0. Then I'll take 3x plus 2 and set it equal to 0. These are both two-step equations. I can add 4 to both sides. 3x is equal to 4. Divide by 3. X is equal to 4 thirds. And on the right, minus 2 minus 2. 3x is equal to negative 2. Divide by 3. Divide by 3. X is equal to negative 2 thirds. Leaving them as fractions is probably your best bet. You have to get those 4 right to earn a 2, so I'm going to go a little bit faster for the rest. Starting with number 5, we'll use the x box method. 3 times negative 7 is negative 21. Put a negative 20 down here. So negative 21 times a positive 1. Product of negative 21 adds up to negative 20. 3x squared, negative 21x, 1x, and negative 7. This has to be 3x and 1x. 1x times 1 is 1. 3x times negative 7. My two factors, x minus 7, 3x plus 1. On the right, same idea. X box, 6 times negative 12 is negative 72. 14 on bottom. What are two numbers that multiply together to make negative 72 and add to get 14? It's negative 18 and 4. Or excuse me, positive 18 and negative 4. When we write things in the box, 6x squared goes in the middle, 18x minus 4x, and minus 12. So I can split this into 3 times 2. I'll put the 3 across from 18 and the 2 across from negative 4. So this is negative 2 and this is 6. When I want to split this to solve for the zeros, I take 2x plus 6 is equal to 0 and 3x minus 2 is equal to 0. I'll draw a line down the middle. So I subtract 6 from both sides. 2x is equal to negative 6. Divide by 2. X equals negative 3. And on the right, if I add 2 to both sides, 3x is equal to 2. Divide by 3. X equals 2 thirds. For the last two problems, you can solve them as is, but it simplifies the process if you factor out a number first. For example, all 3 of these terms are divisible by 3. So if I divide by 3, or factor out of 3, the x box becomes a little bit easier to manage because I'm dealing with smaller numbers. So here, 7 times a negative 2 is a negative 14. On bottom is a negative 5. So this is negative 7 and positive 2. I'm going to take my 7x squared and my negative 2 from my factored version, put a negative 7x and a positive 2x. So 7x and x, 2 and negative 1. And my factors are x minus 1 times 7x plus 2. And remember, we can put that 3 right here, which carries down from factoring it out earlier. Last one, we can divide all of these by 6. So y is equal to 6 times 3x squared plus 5x minus 12. We do our x box, and 3 times negative 12 is a negative 36. 5 goes on bottom, so this turns out to be 9 and negative 4. We put a 3x squared in the middle, a negative 12 on the right, 9x and negative 4x. So we have to use 3 and 1. 3 goes across from the 9, 1 goes across from the negative 4, 1 times negative 4, 3 times positive 3. And I set these both equal to 0. So x plus 3 is equal to 0, and 3x minus 4 is equal to 0. So subtract 3 from both sides. I get x is equal to negative 3, plus 4, 3x equals 4, divide by 3, x equals 4/3. For zeros, we can ignore that 6 that we factored out.